All right, today's lesson is 4A.5 proofs or use congruent triangles. Before we go ahead and take a look at our 4 proofs for today, there's just a couple of things that I want you to keep in mind. Please remember that first to only trust what is given to you in Alex, or only what is marked in the picture. Um, One tip for you is to go ahead and draw the picture that you see in Alex and mark the givens. This is going to help you to pick which shortcut you can use. There will be 2 things that will be givens, but are not all, but are that will not be given to you, sorry, but are always true. These are the things that I've been calling the hidden parts. They are your vertical angles, which look like this commonly, and your reflective segment or your reflective sides, which look like these. Now, one key feature to tell the difference between them is where are the 2 triangles touching one another. Notice in the vertical angles, they are only touching at one vertex. And notice that in my reflexive segment or in my reflexive side, they are touching at a whole side. So they have 2 vertexes, and then a whole side in between them that they are touching at. And of course, that's the difference. Remember that not only is this keep in mind page telling you what to look for in the picture, but it's also giving you the reason. So when your picture looks like this, you know that these angles are equal and that your reason is the vertical angles. That's why they are equal to one another. And when your picture looks like either one of those, you know that you have a reflexive segment. You can use the reflexive property to say that this side is equal to itself or that side is equal to itself. One of the things we are going to see today in the last example is that when you are given parallel lines, angles can be marked as congruent. And there's 2 angle pairs that can be done. They are the alternate interior angles, which mainly look like this. So we see the top is parallel to the bottom, which makes this a transversal and gives me the alternate interiors here and here. We can see that the right side is parallel to the left side, once again making this the transversal, and this angle is equal to this one by alternate interior angles. And then, of course, the other one that you could see are the corresponding. The difference between corresponding is that when they have the parallels, they're going to be positioned the same way. So the left side is parallel to the left side. There might be a bit of a gap in between the 2 triangles, but there does not have to be. And then this one and this one, the left angles in the 2 triangles are congruent. Likewise, you see the same thing. The right sides are parallel to the right sides, giving this right upper angle congruent to this right upper angle, corresponding angles. All right, let's go ahead and take a look at the first proof that we're going to look at. So remember, when you start a proof, you want to focus right here on the given statements. You should know how many given statements there are, and then you should be able to see that many reasons of given in your proof. So I see 2, 1, 2, and they should be statements 1 and 2. They should be statements 1 and 2. And since this is just a fill in the missing pieces proof, number 1, I'm just going to go ahead and I'm going to fill in those missing pieces. Notice right over here in the corner, I've got you just to remind you to look for the hidden parts. This is going to come into effect for statement number 3. When we go to do statement number 3, we're going to be looking for the vertical angles or for the reflexive side. Okay, so let's go back and take a look. I should see my givens. So I should see this should be statement number 1, and it is. If I look completely at the whole statement, it's all there. Well, nope, I got to fill in this part. So let's come back and look at the given. It says QR is equal to TR is equal to TR. And so that's what's missing here in the given. And I'm going to just fill in the blank. Okay. Now let's go ahead and look at given number 2. Given number 2, and I'm just going to fill in what's missing. I'm just going to fill in what's missing. So it says PR PR is equal to SR, and it says PR is equal to SR, so that's there. What's missing is the reason. Well, remember we said the reason had to be given because it's in that given box. So the reason for both of those givens has to be given. That's just the way a proof works. All right, now we're at statement number 3. And in statement number 3, we are looking for our hidden part. Does it look like the vertical angles that you can see in the lower right corner of the screen, or is it the reflexive side that we can't quite see? Let me zoom down. Let me lower it so that you can see. I don't know about you guys, but it looks like this one to me. I can see this shared point right here at R, meaning that my vertical angles, let me grab that color, are at R. So they're here, which is angle PRQ. Notice that they had to use the 3 letters to name it in Alex because the other angle is also R. And so you can't call this angle R. You cannot name this angle R because this angle is also angle R, and we have to be able to distinguish between them. So you would simply call it T, R goes in the middle, S, T, R, S. R has to be in the middle. It is angle R, but R has to be the middle letter. And they already have the reason for you, which is the vertical angles property. Remember, like I said, not only is the picture telling you what's equal, it's also giving you the reason. It's also giving you the reason. All right, for the very last one, it would be I would send this to the proof. This would get sent to the proof, and I have to come up with a reason. Now, for my reason, I can only pick from my shortcuts. So I can pick from side, 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 oh, side, angle, side, HL that we talked about last week, angle, side, angle, or angle, angle, side that we talked about at the beginning of this week. So those are my 5. And if I just kind of pay attention to the triangle, I can figure out which one it is one of 2 ways. So I'm going to focus on the upper triangle because I don't have to look at both of them. The proof is already telling me that they are congruent, so I just got to pick which one it is. So focus up here. I don't see any right angle, so I can cross out HL. I don't see all 3 sides marked, so I can mark off side, side, side. I only see one angle mark, so I can cross out angle, side, angle, and angle, angle, side, meaning it should be side, angle, side. I've just done elimination based off of what I'm seeing in there. I could also come back and focus on that top triangle, and I could just mark them. Side, angle, side. The A is right between the S's like it is here, and it doesn't look like any of the other ones. Side, angle, side. And then I think it says congruence property. Okay. All right, let's go ahead and take a look at the little bit harder of the proofs, starting with number 2. Let me see if I can kind of get those 2 hidden ones to stay. There we go. All right, so remember, I kind of like this proof better because Alex gives me that validate button, and I can do that at the end of each one. It's not going to let you move on to the next statement unless you do. But I like this proof better because it's going to tell me that I'm right. And once it says my proof is complete, I know I'm correct. All right, so you want to focus right here on your givens. And you're going to go ahead and you're going to click the first send to proof, and it's going to come down here and it's going to send the whole thing to the proof for me. It's going to take and fill out this complete line for me, and it's going to say BC is congruent to EC, and it's going to say given. This whole line will be filled out for you. Okay, that's the first one. Statement number 2, you're going to come to the second send to proof button, and you're going to click it, and it's going to fill out this full second line for you, which is going to say AC is congruent to DC. And it's going to even fill out the reason for you given. Now, what I suggest you do from there is go and mark your picture. Draw the triangle that you see and mark these two given statements. So I'm going to go ahead and mark that BC and EC are equal. Okay, they're line segments. So then I'm just going to put a hash mark. I'm going to mark that AC and DC are equal. So I'm going to put two hash marks. And now I'm going to come to do statement number 3. To do statement number 3, I'm going to compare my picture to these two. Which one does it look like? It looks like the vertical. So now I'm going to go ahead and I'm going to fill out my vertical angles. Okay, I'm going to find them right here at C. This angle is going to be called angle BCA. I have to use all three because there are two angle C's, and Alex won't give me credit if I just call it angle C. And the bottom angle C, I'm going to call it DC. And I'm just trying to make that a little bit darker for you, E. And of course, remember, not only does my hidden parts tell me what to look for that's equal, it's giving me my reason, vertical, angles, and then I think it says, I'm pretty sure it says property. Okay, now I'm going to go back to my send to proof button, and there's one last send to proof button, and I'm going to press that. I'm going to press that last send to proof button, but this time it's only going to fill out this side for me. It's not going to fill out both sides for me. That's because I have to figure out which one of the shortcuts makes these two triangles congruent. Why are they congruent? And remember, we're going back to those five that we talked about: side, 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 angle, side, HL, angle, side, angle, and angle, angle, side. So you want to focus on one of your triangles, and you're just going to label the sides. I think I kind of like that one better. So it's side, angle, side. I see the A right between the S's. If I were to draw the line for the angle, if I were to draw the angle, everything is on that angle mark. This is side, angle, side. Okay, remember the order matters of the name of the shortcut. The order matters. And so since the A was between the S's, I'm going to use side, angle, side. Plus my other ones with angles have two A's, and so I can't use them anyways. All right, let's go ahead and take a look at another one. So when you see your proof, remember, you're going to go ahead and focus on your givens, and you're going to send those two to the proof first, and they're going to be your statements 1 and 2. So statement 1 and statement 2 are taken care of for me. All I simply have to do is press this button right here, and it's going to fill out this whole segment for me. And then I can press this button here, and it's going to fill out this whole segment for me. It's going to put in the first one, AC is congruent to EC. The only thing, it's even going to put in given. The only thing I wish it would do is it would actually go ahead and mark that for you, because that's always the part year after year that everybody's, this is so hard, I don't get it, I don't get it. And it becomes quite simple once you draw the picture and you mark the sides. Once you draw the picture and you mark the sides, it actually becomes much, much clearer. ABC is congruent to angle EDC. This angle is at B, and this angle is at D. I know that because that's the way I name angles. I always put the vertex in the middle. So if I were to mark this angle, it would be here at B. And if I were to mark that angle, it would be here at D. Okay, now I have to come to my hidden pictures, and I have to compare my drawing to these two. I have to figure out which one does it look like. it looked like this one because it had that middle in there. So I'm going to come back. Yep, it had that middle. There we go. So I'm going to go ahead and say for statement number 3, I want to mark that those angles are congruent. I want to mark those congruent angles at C. Now, I cannot call this angle C. I need to call it a CB is congruent to, and then I can't call this one angle C. I got to call it DCE. I'm doing the C a little bit darker just to remind you that the vertex has to be in the middle when you name it. And then, of course, not only is my hidden parts hint helping you to find what's equal, it's also giving you the answer as to why they're equal. The vertical angle property is what you're going to pick. And now you're ready for the last statement, which is your last send to proof. But remember, it's only going to fill in this part, and you've got to come up with the reason. So it's only going to put in here that triangle ABC is congruent to triangle EDC, and you've got to figure out why. Remember, this is your side, 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 angle, side, right? So take a look at one of the triangles. I don't know why I always like to look at the top one. I see a side, I see an angle, I see an angle. So I have two choices. Is it this or is it this? Okay, so what I have to do is I have to look at where that S is. If that S is in between the two letter A's, I'm going to pick this one. If the S is not in between the two letter A's, then I'm going to pick the other one. So I have to go back and I have to look. It's side, angle, angle. So the S is only by one. If I were to draw them, notice that only two of them are together and the one is left out. The S is not in between the letter A's, so I cannot do this one. This one doesn't work because the S is in the wrong spot. It's this one because the S is now in the correct spot. Okay, so I'm going to pick angle, angle, side. All right, we have one last one to cover today, and it is the hardest one because it is going to have more than 4 steps. This last one, which is number 5, is going to have 6 steps. If you go ahead and take a look at your givens here, they are not the givens that we have been seeing in examples 1, 2, and 4. Notice that the first example says that F is the midpoint of HE. I'm going to go ahead and start my proof there. Remember, we always start by sending to the proof, and it's going to send the whole thing to the proof for me. So let me get that sent to the proof. Of HE. And of course, it's going to put in there given for me. Okay, now because I know that this point is in the middle of this line, that means I know that this part is the same length as this part. It has to be. Think about it. If this whole line is 10 and this is right in the middle, it would be at 5 and 5. It would be at 5 and 5. So for statement number 2, I'm not going to go to the send to proof. I'm going to actually say that EF is congruent to HF, and my reason is going to be the definition of midpoint. So what I'm using here is I'm using the definition of what midpoint means. And you're going to have to do that in the proof. You're going to have to use the definition of midpoint. You may also see the word bisector in yours. Bisect does the same thing that midpoint does, cuts it right in half, cuts it right in half. All right, now for statement number 3, I can go ahead and grab my second send to proof and send the whole thing to the proof. This one's going to be tricky, guys. Notice that this given is not telling me that GH and DE are equal. It's telling me that they're parallel. It's telling me that they're parallel. So I'm going to grab my pen and I'm going to say GH is parallel to DE. Okay, and of course that it would also fill in the given, sorry. Now remember on my keep in mind page, there was that one down at the bottom that I had to keep in mind when I'm given parallel angles. When I'm given parallel sides, I have equal angles, and I have my alternate interiors or I have my corresponding. If we go back and look at that, if you rewind the video back to that spot, you'll notice that this picture looks a little bit more like the alternate interiors, and that's the one I'm going to use. Since these two are parallel, this becomes a transversal, and the angle here at E is congruent to the angle here at F because they are alternate interior angles. So I'm going to say the angle at E, and you could call this angle just E because it is the only angle E in the picture. Alex should count that right. But if you are worried, just slap the D and the F at either side. Okay? D on one side, F on the other, E in the middle. Okay, and then congruent to, it would be this angle here at H. And you should be able to call it angle H, and Alex should count that right. But once again, if you're worried, put the G on one side and the F on the other. And you're going to pick the one that has alternate interior angles are congruent. Now there might be two of them. It should be the one that says if the angles are congruent, or if the sides are parallel, then the alternates are congruent, because notice right above I see the parallel. But there's only two of them. There should only be two. And so if you pick the wrong one and it won't validate, just go back in and pick the other one that says alternate interior. You're not going to use alternate exterior. And for this one, you're probably not going to see corresponding. Okay. Now it's time to look over here. Now it's time to look over here. So now we've moved from statement 3 to statement 5. But it's always that statement right before the proof that I've got to find these hidden parts. Okay, so I'm looking to see which one does my picture look more like. It looks more like the vertical angles. Once again, they are quite popular. So I'm going to go ahead and say that the two angles there at F are congruent to one another. So statement number 5 is my hidden parts statement. And I'm going to say this angle F, which I'm going to call EFD, is congruent to this angle F, which I'm going to call GFH. And I'm going to say vertical angles property. And now I'm ready for my very last send to proof. Now I'm going to go ahead and click my last send to proof. Remember, it's only going to send this part. You've got to come up with the reason. So you've got to decide, is it side, side, side? Is it side, angle, side? Is it HL? I don't think so. I don't see a right angle. Is it angle, side, angle, or is it angle, angle, side? So I've already ruled out HL. There's no right angle in there. I can see that, right? I don't see a right angle. I'm going to focus on one of them. Now, this gets a little bit confusing because it looks like there's 4 different marks. But remember, this mark is not an angle or a side mark. That is a parallel mark. So I really could come in there and erase that for you. But remember, that's not one that you're focusing on. You're looking at the angle here at the top, the side, and then the angle here at the bottom. So we have angle, then a side, then an angle. So remember, you're looking at these two. Where is the letter S? Is it right in between, or is it only by the one letter A? Well, it's right in between. So I'm going to go ahead and pick this one, and this one is ruled out. So I'm going to say it's angle, side, angle. Hope this helps.